So now that we've used the least common denominator to add and subtract rational expressions, we can use the same idea to help us solve rational equations. So basically a rational equation is any equation that has at least one rational expression in it. Now, in past lessons in Algebra 1 and early on in Algebra 2, when we've had linear equations that have had fractions in them, what we've basically told you to do is to find the least common denominator and use the least common denominator to clear all of the fractions so that you are left with just the given simple equation without any fractional parts. And so that's basically what you're going to do here. You're gonna try to find the least common denominator, and you're gonna multiply it times everything across the equation, hopefully clearing out all of the denominators and being left with just a simple algebraic equation. And so it doesn't require us to change every single rational expression in the equation, but it still does require you to understand least common denominator. So if you take a look here at some of this information, you can look at example number 1, and I'll just go through example number 1 with you real quick. We have a rational equation. We have x minus 3 and x plus 3, and you can quickly see that if you factor out the x squared minus 9, you also end up with an x minus 3 and an x plus 3. So we have all of our given parts here. So we can see that x minus 3 and x plus 3 is common across all of the denominators, and so we're going to use that actually to multiply to both sides of the equation. And when you do that, you actually end up canceling out different parts of the denominators so that you're left with just a simple algebraic equation. Now, here's the problem. If you multiply both sides of an equation in algebra by an algebraic expression, you then introduce the idea of an extraneous solution. So whenever we do this in rational equations, we have to check for extraneous solutions on the back end. And you can see in example number 1 that we check both of the solutions plus and minus 1 for extraneous solutions, and they both work out. So be sure to always check for extraneous solutions. So in the next couple videos, I'll just go over some sample problems. If you'd go ahead and get started and try to work those sample problems, you can come back and watch the videos for the solutions.